Welcome to the deep dive. Today we're planning to cut through some of the noise around networking. We're looking at a really foundational technology, something that quietly enables, well, a lot of our secure and efficient digital lives. It's called virtual routing and forwarding, or VRF. Now, I know that might sound like a bit of a mouthful, maybe quite technical, but don't worry. VRF is actually a cornerstone of how modern networks operate. It's working behind the scenes, constantly, making sure your data goes where it's supposed to. And maybe more importantly, only where it's supposed to.
Exactly. And that's really our goal today. We want to demystify VRF a bit. We'll show you not just the what, but the why it's so indispensable. You'll see how it creates the kind of online privacy and security we all just sort of expect now. Whether you're streaming a movie or, working on sensitive company data.
Right. It's that virtualization aspect that's so ingenious, isn't it?
Yeah.
Taking one router and making it act like, well, many distinct private networks. And we've actually got a pretty helpful analogy coming up to help visualize this. But first things first, let's get right to it. At its heart, what exactly is virtual routing and forwarding?
Okay, so VRF is essentially a core networking technology. It lets you take a single physical router and partition it, basically slice it up into multiple completely separate virtual routing instances. Think of it like having one powerful piece of hardware, but inside it, you effectively have several independent routers. Each one operates as if it were a standalone device. Its fundamental purpose is creating these isolated network environments, but all on shared physical gear, this digital separation. It's really foundational to modern network security and just the whole architecture.
That's quite something, taking one physical box and making it behave like many. I'm already trying to picture how that separation works in practice. Can you give us maybe a relatable comparison, something to clarify it?
Absolutely. Yeah, the best way to wrap your head around VRF is probably to think of a router as, let's say, a grand, luxurious hotel.
Okay, a hotel. I like it.
Right. So in this hotel, a virtual routing and forwarding instance of VRF is like having an entire, completely private floor, a floor dedicated just to a specific VIP guest, or maybe a whole group of VIPs.
Ah, okay, like the penthouse suite level.
Exactly. And the VIPs on that floor, say the penthouse floor, they can't see or access any other floors in the hotel. They exist in their own secure, isolated environment. They've got their own amenities, their own services. Crucially, their whole experience is entirely separate and private from anyone else in the building. Even though physically they're all inside the same building, sharing the same foundation, maybe even the same main elevator shaft sometimes.
That's a really vivid analogy. It definitely clarifies the whole isolation idea.
Yeah.
Okay, so let's unpack this a bit more then.
Yeah.
How does the router, our grand hotel, actually achieve this separation? How does it physically manage the isolation? Because like you said, it's not like each floor is in a different building, right?
Precisely. It's all about logical separation, yeah. But it's enforced through some very specific mechanisms. So, sticking with our hotel analogy, there are two main ways VRF creates this privacy within that single physical router.
Okay.
First, each floor, each VRF gets its own private address book. Or think of it as an internal map. In networking, we call this a routing table. So if you're on the third floor, the concierge that's our router only looks at the map for that specific floor.
Right.
There is absolutely zero crossover. The routes, the pathways for data, the rules for getting from, say, room 301 to room 310 are totally distinct from the rules on the fifth floor or the penthouse. Each VRF has its own unique set of routing rules and pathways, completely independent.
Okay, so separate maps for each floor makes sense. What's the second mechanism?
The second thing is dedicated elevators. This is analogous to what we call assigned interfaces in networking. An interface is just like a port, basically a connection point, a door into the router. So, if you're a guest on the penthouse floor, you might use a private, keycard-activated elevator that only goes to the penthouse. If you enter through that specific elevator, that specific interface, you can only access the penthouse floor, the penthouse VRF. This means data traffic from one virtual network is logically stopped, prohibited from even seeing or interacting with traffic from another virtual network. It's like having multiple distinct entrances and exits on the same router, but each one leads to a completely separate, segregated virtual network inside.
That really paints a clear picture. So it's not just some kind of, imaginary boundary. It's literally different entry points and different maps for each isolated network, all managed by the same piece of hardware. That's clever.
It is. It highlights how robust the isolation can be when it's implemented correctly.
So, okay, we have this clear picture now of the mechanics, the isolation. The obvious question for a lot of listeners is probably going to be, so what? What's the real-world advantage? Why does this matter beyond just, clever engineering? What are the tangible benefits? Why is this tech so indispensable?
Right. Good question. The why for VRF, it really boils down to three massive advantages. We're talking truly granular security, incredible operational efficiency, and actually significant simplicity and cost savings,
Okay,
too.
let's break this down. Security first.
Yeah, let's start with truly granular security. What's really profound here is how VRF offers security divisions, granularities, that even traditional methods like VLANs or firewalls can struggle with, especially at scale. VRF lets a single router enforce security policies as robustly as if you'd actually deployed completely separate physical networks, but crucially, without the huge cost or complexity that would involve.
Just like microsegmentation built right in.
Exactly. It's baked directly into the routing fabric. So back to our hotel. The hotel's public Wi-Fi network could be a VRF1. Anyone can connect. But the secure network running its internal operations, reservations, guest billing, maybe staff communications, that's VRF2. VRF ensures these are completely, totally separate. An attack on the public Wi-Fi just cannot cross that VRF boundary. It can't get to the sensitive internal data. So this lets organizations isolate critical departments or sensitive data or even specific apps all within the same physical device.
That's a huge security benefit.
Yeah.
Okay, what about the operational efficiency you mentioned?
Right, the second big one. Operational efficiency through no IP address conflicts. This is a really common, sometimes painful problem in networking. Different networks often want to use the same internal IP address ranges, like 192.168.1
Oh,
something.
yeah. Everyone uses those at home.
Exactly. So without VRF, imagine if two different customers of an internet service provider both used 192.168.1.1 for their main device. The ISP's router wouldn't know which customer's device to send the traffic to. It would just cause chaos. But with VRF, it's like our hotel having multiple room 101s, one on the third floor, one on the fifth floor. Because each floor, each VRF is completely separate with its own map, there's no confusion at all.
I see. The context of the VRF tells the router which room 101 is the right one.
Precisely. And this capability is absolutely essential for service providers, ISPs, cloud providers who manage vast numbers of customers. Customers often have identical internal network setups. VRF dramatically simplifies the provider's network design, and it gives them incredible scalability without constantly having to re-architect everything.
Okay, that makes a lot of sense. And the third benefit was simplicity and cost savings.
Yes, simplicity and significant cost savings. First, by organizing what could be a massive, incredibly complex network into these clean, manageable, isolated sections, VRF dramatically reduces the overall complexity for the network administrators. And then there's the cost. Instead of buying a separate physical router for every single private network you need, which would be incredibly expensive, take up loads of physical space, consume lots of power, VRF lets you use one, maybe more powerful, physical router to host many virtual ones.
Right, fewer boxes, less power, less cooling.
Exactly. It leads to direct cost savings. You need less physical hardware, less maintenance for that hardware, lower power bills. It adds up quickly.
It's really pretty amazing how much is happening behind the scenes, isn't it? We use these services every single day, completely unaware of this intricate, almost invisible architecture that's making it all possible. So whether you're hopping on public Wi-Fi at a cafe or logging into your company's secure network or using some cloud service, chances are this VRF technology is quietly working away, making things more secure, more efficient, and more reliable for you. It really is kind of an unsung hero of the modern internet. So given these really profound benefits for security, efficiency, cost, it really begs the question, who are the main users? Who are the big players, the organizations putting this incredible technology to use every single day? Where does VRF's impact truly, ripple through our digital infrastructure?
Oh, the list is extensive. It really spans almost every sector of our digital world. But two primary categories definitely stand out: internet and cloud providers, and then large organizations.
Okay, let's start with the providers.
Right, internet and cloud providers. Think about the giants Amazon Web Services, AWS, Google Cloud, Microsoft Azure, even your local internet service provider, maybe Comcast or Verizon or whoever. They absolutely rely on VRF. It's fundamental to their operations. They use it to securely partition their massive infrastructure for each and every one of their clients. This is actually the very basis of how they offer things like virtual private clouds, or VPCs. When you sign up for a cloud service and get your own private space, VRF is what ensures you get your own secure, isolated slice of that huge cloud infrastructure. It keeps you completely separate from every other customer, even though you're all sharing the same physical data centers and the same underlying network equipment.
So it enables that whole multi-tenant model securely.
Exactly. It's critical for multi-tenancy. And then the second group, Large organizations, these depend heavily on VRF too. We're talking about large enterprises, hospitals, universities, government agencies, you name it. They use VRF to securely manage their own, often incredibly complex internal networks.
Can you give an example?
Sure. Take a hospital. A hospital needs to ensure that its financial operations network is separate from its patient data systems. And both of those need to be separate from the public Wi-Fi they offer visitors. And all of those need to be separate from the critical networks controlling medical equipment, maybe life support systems. VRF allows them to do all this segregation, but using shared network hardware. It isolates critical departments and functions. It prevents potential security breaches or even just operational problems from spilling over from one part of the network to another. It contains the blast radius, so to speak.
Wow. So yeah, this isn't some obscure niche tech that only a few network engineers care about. It sounds like it's a fundamental building block for, well, practically every large-scale digital operation we interact with daily. It's enabling the very services and experiences from streaming movies to secure online banking that we've all come to expect in our interconnected world. And just like that, we've reached the end of our deep dive into virtual routing and forwarding. So what does this all mean for you listening in? Well, we've seen how VRF takes a single piece of hardware or router and transforms it, turns it into many isolated secure networks. And this provides powerful security, efficiency, and cost savings that are, frankly, essential for our modern digital landscape.
Yeah, what's really noteworthy here, I think, is how an essentially invisible technology like VRF creates this secure, segmented digital world that we, often just take for granted. It's foundational to this whole concept of multi-tenancy, of secure data separation on shared resources. And this brings up maybe an important question for all of us to think about. As our networks become even more complex, even more interconnected, more devices, more data, more users, how will these foundational concepts like VRF, how will they need to continue to evolve to meet that ever-growing demand for both sharing resources efficiently and maintaining unyielding isolation? How are we going to balance that need for connectivity with the absolute necessity of privacy and security going forward?
That is a great question to leave us with. It really makes you think about that invisible architecture that keeps our digital lives safe and functional. Well, thank you for joining us on this deep dive into the world of virtual routing and forwarding. We hope you walk away with a clearer understanding and maybe a renewed appreciation for the ingenious engineering that underpins our connected world. Until next time, keep exploring.